Hello, my name is John Kelly, and this is the Weber Auto YouTube channel. This will be the fifth and final episode on the world's first mass-produced automatic transmission, the General Motors Hydra-Matic transmission, produced from 1940 through 1955. This episode we will reassemble the entire transmission. In the previous episodes, we've looked at the individual components, the operation of these parts, the power flow, the hydraulics, the fluid coupling, and so on. But now it's time to put it all back together and set it on the shelf and move on to the next transmission. So to begin with, I want to make some corrections from some errors in the first 4 episodes of these videos. And a big thank you to Aaron Severson of 8upwithmotor.com, a wonderful historical website with lots of automotive history and including a tremendously detailed history of the automatic transmission. Much of the information I've given you in the 4 previous videos has been taken from his website as well as a few other websites and U.S. patents and so on. So there were several corrections that need to be made. In one of the previous episodes, I referred to a Thomas Kelly when it should have been an Oliver Kelly or OK Kelly. He's the one that had the patent for the fluid coupling that finally allowed all of the individual pieces, some that had been around for quite a while and used in other transmissions, but none of them had been synthesized or put together in one big operating component like this original Hydra-Matic transmission. Another correction I need to make is that I told you in 4th gear that this transmission was locked up solid with a 1-to-1 gear ratio from the back of the engine crankshaft all the way to the transmission output shaft. That is not correct. I was wrong. The transmission, through its front planetary gear set to the engine, is locked up 1-to-1, but the rear planetary gear set is not locked up 1-to-1. It's still driven off the turbine or the driven torus member inside the fluid coupling, and it does allow for some slip. This is called a torque split. About 60% of the torque in 4th gear comes through the torus, through the front planetary gear set, and out the rear planetary gear set through the ring gear. But the sun gear of the rear planetary gear set is still connected to the turbine inside the fluid coupling, and that contributes with a little bit of slippage inside the fluid coupling, the other approximately 40% of engine torque. Now, of course, that varies a little bit based on how fast you're going. The faster you go, the more torque it will contribute, because there's less slipping with higher speeds in the fluid coupling, and obviously more slipping at low speeds. This same type of torque split is used in 3rd gear also on this transmission. Another error that I made was in the power flow video. I told you that the reverse gear set was used to get reverse. That's partially true. It's the combination of the rear gear set and the reverse gear set. They act as a compound gear set together to get reverse. And it's actually the rear gear set that does the reversing. The reverse gear set just adds an additional, or multiplies an additional gear set in there for the reverse gear ratio being much numerically higher for additional torque in reverse. Another error I made was in a discussion of what was called the reverse blocker valve on the governor body. I told you that the reverse blocker valve would stop you from going into the reverse as long as there was some vehicle speed. Turns out there's both a park blocker valve and a reverse blocker valve in that same body. The park blocker valve is operated by line pressure and will prevent you from engaging that reverse anchor, that parking pawl, as long as the engine is running. You can still move the gear selector to a park position if it has one, or the reverse position, and then as soon as you shut off the engine, it will engage that anchor. But the reason we don't want that engaged when you go to reverse is if you need to rock the vehicle out of being stuck in the mud or snow or something. You can quickly go between reverse and low, which is why they put those two right next to each other on the gear selector, without having to engage the reverse anchor or parking pawl. The reverse blocker valve that I spoke to you about physically prevents you from moving your gear selector into reverse as long as you're moving approximately 4 miles an hour or faster, because it has fluid supplied to it from the governor, which is a vehicle speed sensitive or proportional fluid. So anywhere from 4 miles an hour down, you can put it in reverse, and like I said, that's to help rock you out of being stuck in the mud and so on. If you go back and look at some Chevrolet videos on their first Power Glide transmission, it shows a dirt road and somebody stuck in the mud and having to rock between forward, which would be low on the gear selector, and reverse, and rock themselves out of being stuck in the mud. Back then, there weren't as many paved roads as there are today, and so that was a feature. They purposely put low and reverse right next to each other. All right, well, I think we are ready to start reassembly of this transmission. As I showed you in the previous episode, I have a holding fixture here where I can rotate this heavy cast iron case in any position and install the parts. And so before we can put the parts in, we have to put some of them together. From the power flow video that I shot, I left out some of the clutch packs so that we could actually see what was going on with the planetary gear sets. Well, now I've got to put those together. So let's start by putting together the rear clutch pack. Okay, I've got the components here of the rear clutch pack. The rear clutch pack goes in the rear drum here, which of course the rear band would wrap around and stop from rotating. The rear clutch pack is going to go inside of this and connect to the rear unit clutch hub, which is connected to our intermediate shaft, and when it applies the clutch, it will force this whole assembly to rotate. So we're going to reassemble this rear drum and clutch pack. So to begin with, we have the rear cover that would go on back here of this clutch drum, and we've got a clutch piston that's going to fit down inside here. It has a lip seal right here with the brass expander ring inside of it that I showed you in a previous video. This is the one for the front clutch pack. It has an inner seal down inside of there that fits up inside of this aluminum piston, and we need to lubricate both sealing surfaces with some transmission assembly lube, or just transmission fluid is fine. Just coat everything really well. And the service manual tells us to install this. We need to put it down in the bore. It does have a slight taper so that the lip seal will have something to compress it slightly as you rotate it down in. But put it in the bore and rotate, and it drops right down in. Now I installed the old seal with the expander ring because the new seal that I got in the overhaul kit is a modern design that doesn't use the expander rings. And I wanted to keep this transmission correct for the period that it came out of. And so I'm just reusing the old seal. This transmission is never going to be put back in a vehicle anyway, so it doesn't matter if they're new seals or not. But if I was building this to go in a vehicle, I would install the new seals without the expander rings. All right. Then there are some slots in the piston that have to line up with holes in the rear clutch cover here, and those make room for these guide pins that are inside of the drum itself. All right, we are going to assemble the clutch pack inside of the drum. Before we do that, we have to put the rear unit internal gear back on. So the internal gear, or ring gear if you want to call it that, has got to go back on the back of this. That way the return springs have something to fit against. There's two little flathead screws that hold the ring gear or internal gear in location while we assemble it. And then there are 6 heavy bolts that will bolt this ring gear or internal gear to the rear clutch drum once the transmission is finally assembled. Okay, so we're just going to alternate fiber, steel, fiber, steel. There's round notches that will line up with the 6 return springs. There's squared notches that line up with the alignment dowels. There's 8 fiber plates. There's 8 steel plates on this model. Just like that. Okay, now we will put the return springs in the rounded holes. There is a height specification for these return springs where you measure them to see if they have been compressed too many times. And there's an inner spring and an outer spring that go together. If the springs are too short, then you replace them. But good luck finding replacement springs in this day and age. All right. Our next step with the return springs installed is to put the, what's the official name? Rear clutch cover back on. To do that, I have to take off my label or it won't fit because it's a very, very tight fit. We'll line up the 3 holes in the back of the rear clutch cover with the alignment dowels. Just like that. I think maybe I'll put just a little bit of lube on the outside of this. And carefully drop it or guide it down in place. There we go, just like that. All right, now there's a snap ring, and we have to go over to the arbor press, press this clutch cover down against the return springs enough to put the snap ring in place. So let me do that. Okay, I've got the snap ring installed. I just used an arbor press to push down just enough, don't go too far, just enough to get that snap ring in the outer edge. You can see the opening right there in the housing. All right, the other thing we have to do here is turn this over and get the rear unit clutch hub lined up with all the clutch plates and get it down in place. So it helps to just manually line them up, especially with 8 clutch plates. It's quite a chore to get all those lined up. I've got the clutch hub here. I've got a brass bushing on each side. By the way, this transmission has no bearings in it, no bearings at all, except for a roller bearing in the tail shaft housing to support the output shaft. That's it. Everything else is just brass bushings. And I hold those bushings in place with a little bit of transmission assembly lube so that they don't fall out when I turn it over. All right, I'm going to line this up and carefully try to get it to drop down in place. We're almost there. The last one is a fighter. I may have to put the intermediate shaft in here to give me some leverage to turn this thing. Ah, there we go. I turned it, it dropped down in. All right, now there's a special service tool that's just a metal bracket that comes over and holds that clutch hub in place while you put it back on the intermediate shaft and while we set the whole thing down inside the transmission. I do not have that special tool, so I will have to come up with an alternate method or make it. It's just simply a piece of metal that's bolted in place with one of the 6 bolts that hold the ring gear in place. All right, so that is our rear clutch drum. Let's set that out of the way and let's bring in our front clutch and we'll do the same thing with it. All right, I've got the front clutch drum right here. It has the same 3 alignment dowels, but this clutch only uses 4 fiber and steel plates for the front unit. So we'll line the plates up the same way. It has return springs just like the rear clutch hub had to return the clutch piston back to the released position. Just like that. Then it has the return springs with the inner and outer spring. 6 of them, just like the rear. We also have 6 little what are called spring guide pins right here. These pins keep the springs from buckling as they compress. And I just realized these springs need to go in, or these guide pins need to go in this rear unit, not the front unit. So I'll have to take that snap ring off and drop these down in the center of the return springs before we go together. The front unit does not use those guide pins. All right, so I'll set that off to the side for a moment. We need to install the clutch piston for the front gear set. But before we do that, we've got to put the piston ring or piston seal expander and piston seal back on. I'd never seen these expanders before, so I read up on them, and the way you install them is to put the expander on the piston first, and then you work the lip seal on over the expander. And the book tells us not to have any of this brass expander sticking out past the seal itself. I'm going to take the seal, work it in the groove behind the expander, and do not bend the brass expander. Just takes a little bit of patience to get that in place. Just about got it. There we go. All right, got the lip seal fully installed. Go around and make sure that the brass expander is not protruding up. And then we need to put the front clutch piston into the front clutch piston cover. So we will lubricate where those seal rings or those lip seals will go down in. I'll lubricate the inner seal. I've already installed it with its brass expander ring. Everything's slick. A little bit of lube on the seal itself. And then the book tells us to rotate the seal down into place. So push it down in and push and rotate at the same time. Got to push down evenly or it won't want to go. There we go. Right down in where it should go. Then we'll line up the holes, the alignment holes, the alignment dowel holes with the piston so it can go through just like that. So now the clutch cover and piston are ready to install in the clutch drum itself. Okay, a little bit of lube on the outside of this piston cover, clutch cover. And then we'll line it up. There we go. Now I just go over to the arbor press and get that installed, as well as putting these spring alignment dowels in the springs for the rear clutch housing. So put these pins in. All right, alignment dowels are installed. I just need to get this snap ring installed and we'll be in good shape. All right, I've got the snap ring installed in the front clutch drum. The overhaul instructions tell us to tap the clutch cover with piston in it, which is this sun gear here, down so it goes against that snap ring we just installed. It shows using a block of wood. I've got a soft hammer instead. It also says to do that on this rear one. That way we've got all of the clutch pack clearance necessary so that when the clutch is not applied, the clutches are not rubbing on each other. I did not see an actual measurement for clutch pack clearance on this transmission. I know most newer transmissions have a clutch pack clearance that you adjust. if it's incorrect. Perfect. All right, the service information calls for a special tool, which is nothing more than a bracket, to hold this clutch hub from falling out when we install it on the intermediate shaft and then install the shaft down in the transmission. I just got a little piece of metal, cut it to a length that I liked, and I'm just going to use one of the 6 bolts that holds the ring gear to the output shaft and hold that gear from coming loose. All right, the next step in reassembly is to take our intermediate shaft with our front unit clutch hub right here, that's also the front unit planet carrier, and install that into the front clutch pack. So all of these teeth right here have to line up with the clutch plates inside of this housing here. So we've got a bushing down inside of here that'll ride against the sun gear. Get this lined up. Those clutch plates are not, oh, there it went, some. Closer. One more, I think. Aha. No, still one more. If we don't get a nice metal to, oh, there we go. If we don't get a nice metal to metal clunk, we're not down on the bushings. Okay, so we've got that installed. There's a bushing and a snap ring that go in here on the back side to hold that in place. It has a little notch in the spacer on the other side of the bushing that has to line up with a notch. There we go. That is lined up. Then a snap ring. And finally get the snap ring all the way in. That's the snap we like to hear. Now everything is good and solid. We've got the snap ring down inside. And we are ready to install the oil delivery sleeve. If you recall, the oil delivery sleeve fits down in the transmission case underneath what looks like a main bearing cap. Take this cap off of here. So we've got this cap right here, or a rod bearing possibly. It has a hole right there that is going to line up with this hole right here. That will keep it from rotating. And then the long part of it faces backwards, or towards the rear of the trans. The short part of the sleeve faces forward. The cap itself needs to face a certain direction. Install the new center bearing cap lock plate and attaching bolts on the center cap. Tighten the bolts gradually to 40 to 50 foot-pounds. It does not say that it fits, that it goes one way or the other. But when I took it off, there's kind of a chamfer or a machined edge on one side, and well, I guess they're both machined. A flat machined surface on one side and a raised machine edge on the other side. I believe the raised machine edge was facing backwards. So this is the front clutch, the short portion of this oil delivery sleeve. The oil delivery sleeve is where front clutch fluid will come through this hole, and rear clutch fluid will go through this hole and up through these cast iron seal rings, up into some holes in the clutch drum behind the clutch piston, and apply the clutch pack. So I've already installed the seal rings on the sleeve. I've got these original Kentmore Tools ring compressor here, which just makes it easier to install the sleeve. It doesn't make it, I mean, it's not impossible to do if you don't have it, but it's a lot easier to do if you do have it. The inner ring is in, but the outer one isn't quite in. Let me turn the tool around. Try that again. There we go. Okay, so that's in all the way. By the way, these seal rings sit inside of the drum and spin with the drum inside of the grooves of this oil delivery sleeve. So we always want to make sure that they're nice and free and aren't bound up at all. All right, the next step is to install one more snap ring that will hold the back of this rear clutch hub in place. So I've got another snap ring right here. I'll get that in its groove here, just like that. Then the hub will go on right here, and one more snap ring. So let's take the hub, which is very heavy now. It has all these pieces in it. We'll line up the splines. It won't slide on to the oil delivery sleeve until we compress the cast iron seal rings. We'll compress it. We've got one on. One more to go. Make sure everything is lined up, yes. And there we go. Got it fully installed right there. Now we've got a snap ring that's going to go and hold that other hub, or the other end of the hub, in place. It's a good thing we put that bracket right there, because all that hub would have pushed out and disconnected all 8 of those clutch plates again, which would not have been fun to line all that up again. And there we go. Snap ring installed. This whole assembly now is good to go. Now, we have the front band and the rear band that need to go around these. So we've got to get them over here and around the outside before we set them down in the case. Oh, I found a note on the cast iron bearing cap. The cast taper on the bearing cap should be towards the front unit. Tap the bearing lightly to place into place with a hammer or brass drift. The taper is on the top of the cap, and I did have it right. The taper faces the front, but this raised machine surface faces the rear. So here's the cast taper. Here's the raised machine edge. Okay, to put all of this in the case, remove the front and rear planetary gear sets from a holding fixture, which we didn't have to assemble these. We'll just use the bench. Position the front band over the front unit drum so the short anchor end will position to fit over the band adjusting screw when the units are placed in the case. Install a suitable spring or wire to hold the front band onto the front drum when installing. Alright, so Here are our front and rear bands. It tells us to position the short. So here's the long one, here's the short one right here. Position, so the short anchor end will be positioned to fit over the band adjusting screw. So the band adjusting screw is down in the case here, comes in from the top of the transmission. So we want this facing down, just like that. So we will put this over the front drum. Be careful not to damage the band. This band still has lots of good material. They want us to tighten this up somehow. I am going to use a zip tie. So I'll compress this thing. Looks like it's going to take 2 of these shorter zip ties. Now we've got to be careful that we position that oil delivery sleeve in the right orientation so that the bearing cap dowel can hold it in place. So the procedure is to bring this in on an angle. Let me slide this band up. Come in the front here. All right, let's position that oil delivery sleeve about right there. That's where it needs to be. The bearing cap, once again, has the little notch underneath. The tapered edge of the cap facing the front. And I'm going to set that down in, line it up with that hole. Make sure that it drops in place as it should. It's not lining up. Needs to be adjusted just a little bit. The hole is off just slightly. Let me see if I can rotate it here a little bit. There we go. Aha, there we go. The cap dropped right down once the hole lined up there. All right. And then it tells us to gradually tighten the bolts to 40 to 50 inch-pounds. I'm going to, or foot-pounds, I mean. Let me get on foot-pounds here. I'm going to go to, I'm only going to torque it to 40, so I'm going to do 20 to begin with, and then 40. Okay. There's 40. I'm going with a lower torque just because these are old bolts. And old threads. I've learned over the years that they tend to strip out if it's been apart a lot of times. Now there's some little locking tabs that I'm supposed to bend up and keep those bolts from coming loose. For this training transmission, I don't want to bend those back up because if I ever take it apart again, they will probably break. You can only bend those so many times. All right, I'm just going to cut the zip tie here, holding the front band in place. Rotate that down. Uh-oh. We may have had a learning experience here. I think we can do it. I should have rotated it down before I tightened the... Oh, there we go. Okay. Bearing cap in place. Okay, get that on top of the threaded band adjuster. Yep. We are there. Okay. So we'll let that sit for a moment and see what the next step is. All right, our next step is to get our front unit internal gear with its bushing down inside installed. It has the oil pump drive key right here that is going to slide into the notch in the rotor of this variable capacity oil pump, which, by the way, was patented. The patent was applied for in 1950. That was the first time that we had a variable capacity pump, to my knowledge, based on that patent. So the book tells us to line up the notch on the internal gear with the notch in our oil pump drive gear. There's also a bushing right here that rides on this machine surface, so we'd better put a little bit of lubrication there, as well as some bushings inside of this ring gear housing. So there's a bushing right there. Just going to put a little bit of lube right there. More just inside here. We'll put some lube on the pump bushing that holds the ring gear in place, and then there'll be a different bushing inside the fluid coupling, or the torus, that slides down over the pump itself. There is a gasket for the oil pump. I'm going to slide that in place here. It's ready to go. Then we'll take our ring gear, our oil pump. We'll line up the drive gear. There we go. And we'll install this whole assembly as one piece. There is, as I've marked here, the suction side of the oil pump, so that's going to face the bottom of the transmission. There's also two little tiny torque converter seal, or fluid coupling, drain back holes right there. So if this bushing up front here leaks, it's still sealed behind this front pump seal, but if somebody gets in there and fills it full of RTV or gasket sealant or whatever it may be, it can block those drain holes, and then the fluid would build up pressure and leak out the seal, even if it's a good seal. So now we will put this whole assembly in right here. We're putting it in as an assembly because we need to keep the oil pump drive gear and that little keyway lined up where they should be. All right, now we've got another bushing and snap ring right here. Brass bushing first. Little protector between the bushing and the snap ring. Holds it in place. And then the snap ring. Snaps in place just as it should. All right, Now, this oil pump can rotate. We don't want it to rotate, but there are some alignment. You're supposed to make an alignment mark when you take it apart. This particular pump has a little notch in the case over here. So I've got this rotated incorrectly. Let me take a picture of that so you can see it. It has a notch in the housing of the oil pump, and there's supposed to be a little sleeve, a metal sleeve that fits in there. Now, either I lost that sleeve when I took the transmission apart the very first time, or it was not there. I suspect somehow I've lost it, but I've looked and I cannot find it. There are 2 bolts that will hold this in place, hold the pump in place. We are not going to tighten those yet because we need to get the pressure regulator installed on the side of the transmission. So the pressure regulator here goes into a hole in the oil pump, and as we saw before, it will regulate the internal pressures of the transmission. It will also control the variable volume oil pump. It has a copper sealing gasket, and it has an O-ring right there to seal off some of the boost passages. There are 2 things that will boost fluid pressure in this transmission, and that was another error that I made in one of my previous videos. When we go to reverse, we want to boost internal line pressure, and so there's a hole right there that is boost pressure for reverse. But there's another hole right here for throttle valve boost. So anytime we step on the throttle, step on the gas, the harder we step on the throttle, the farther we step on the throttle, the higher the input torque to the engine is, or from the engine to the transmission is, and that boost will give us harder clamping loads on the bands to keep them from slipping. I believe it also boosts, well, yeah, it does. It boosts through line pressure right here, the pressure that holds the clutch packs from rotating. This takes a 1 1/4 inch hand wrench or socket to hold it in place. That is our line pressure regulator valve. Now once that is installed, then we can install the oil pump bolts. Oil pump bolts are 10 to 13 foot-pounds. I'm going to go low down to 10 there. Whoa, too far. 10.7. Gotta be careful on these lower torques. There we go, 10.1. All right. The next step is to install the rear band. And so it tells us to slide the rear band in over this drum here, the rear drum, and position the bottom anchor point right here on the band adjustment pin on the top side of the transmission. So that's going to come in right there. And then the servo will push in from the bottom. Now to get that installed, I've got to take off that bracket that I put on to hold the clutch, the rear clutch hub from falling out. And let's take this rear band, position it down over, slide it back. Oops. Gotta have the spring at the top while we slide this over. Wouldn't you know it? It does not want to clear. So it's clear to me that I should have installed the rear band, and as a matter of fact, the instructions did tell me to. I just got it out of sequence. Before tightening this bearing cap down, I don't think I need to take it off. I just need to loosen it. The band won't clear the housing. Got to pay attention to instructions. And to complicate things, because I have the front pump installed holding the output shaft from rotating very far, that may have to come off also to get this rear band on, which will really change. Oh, no, there we go. Almost there. There we go. Whew. All right. Bolts back in. Okay. So we've got our bands in place. We've got the intermediate shaft in place, which is this shaft right here. We have our oil pump in place. Next thing, we better look in the book. All right, our next step is to air check the front and rear clutch packs to make sure that the seals, the oil delivery sleeve, the cast iron seal rings and all that are sealing as they should before we put the rest of the transmission together. So the front clutch pack, I believe, had a torn lip seal, but I put it back together anyway because I wanted to use those brass expander rings. The rear clutch pack did not. So let's apply the rear clutch pack through a hole here on the side of the transmission where the valve body would go, and do the same thing hydraulically. Let's listen for the clunk of the clutch pack applying in the rear clutch. So it applies. Here's the front. I can hear it applying, but there's a leak. And that's the cuts in the seal. Let's go back to the rear. That was the rear. Here's the front. So the front is leaking. If that was the case in real life, you'd want to pull that back apart and repair whatever leak there was before moving on. All right, our next step is to put the output shaft into the tail shaft housing. Before we do that, there is a seal that needs to go in the end here. And we have a special seal driver right here, the official seal driver to install that. So here's our output seal. The instructions tell us to coat it with a gasket cement, some Permatex Indian Head gasket shellac compound. Tells us to do this on both seals. Just paint a little bit of this sealant around the outside edge. This special driver tool here you can hit with a hammer, or I don't like hammers unless I absolutely have to. Use it in a press to just press it in place. Hammers tend to knock out the sealing ring, the girdle spring, that holds it in place anyway. All right, we've got the seal all pressed in. No hammer, sometimes referred to as the swinging press from a previous mentor of mine, Mr. K. Bagley. All right, so on the side of the output housing, here we've got this cover. This is an access hole to get to a snap ring, a bearing spacer, another spacer, that all need to be installed when we put this reverse gear set and the output shaft in place. So we've got a thick spacer and a thin spacer, a snap ring, and the anchor for the cone clutch. Along with the speedometer cable, driven gear, I mean. All right, on our output shaft here, there's a spacer, the thin spacer, that's going to have to go on before the only bearing in this entire transmission, this ball bearing right there, for the output shaft. And that is held in with a snap ring. We have to put the reverse cone clutch back on the outside of the reverse internal gear. It tells us to just take a pair of snap ring pliers and spread this aluminum cone clutch out just barely far enough to get it over this tapered edge right here. So we'll spread that out. There we go. There's a notch in the cone clutch right there where an anchor pin goes in the back of the case. And then it fits right here in the case when we're ready to install it. All right, so the ball bearing that I told you about will go here, and then there will be a spacer and then a snap ring. The snap ring has to be installed through this cover hole right here. There is a cone clutch return spring that goes in the back of this housing right here that I left out on purpose because it would not stay in place. It's a two-piece cone clutch return spring. Let me get that. So there's a two-piece spring. These two tabs right here line up with the two holes in the reverse internal gear housing. And what it does is it sits between the internal gear and the planet gear and will push back on the internal gear to release the cone clutch. So we've got the spring, the holes where it goes, and then the challenge of keeping all of that lined up while reinstalling. I'm going to attempt to use some assembly lube here, some petroleum jelly that melts at a lower temperature than petroleum jelly. Okay, there we go. Let's see if that'll hold it in place while we put this together. Looks like it's not falling off just from turning over right there, so that's good. Rotate that. There we go. So the spring pushes right there. Okay. Let's put this in the housing. So we slide that on. Slide this down. And there we go. So this whole assembly is partially installed, but it won't be fully installed until we get this cone clutch in its groove. Almost there. with the notch at the bottom, which I don't have the notch at the bottom. So let's rotate that around. This is the bottom right here. Now we've got to hold all that in place, drop this sleeve all the way down in from the output side. Come on. There we go. Sleeve dropped. And then we're left with a snap ring that is going to be very difficult to install properly. We're not getting enough clearance for the snap ring yet. What is going on here? Oh, I bet I know. Jeez. All right. That bearing is a fairly tight fit. That ball bearing on the output shaft. I bet we need some lubrication. Right there. I think the shaft just wasn't going all the way through the bearing as it should have. All right, we've got a return spring in place. Coming back in. This time ought to do it. Okay. I remember having to tap that out. I'm going to tap lightly here. While rotating. Turn it over, and haha, that's it. Yes, we have a snap ring groove. So the bearing was just holding up the progress there. We got enough. Actually, it looks like we need just a tiny bit more. I'm going to tap down on the housing. That did it. I usually don't like tapping. As a matter of fact, it's a really bad idea to tap on a ball bearing because of what's called brittling, where you can actually cause little indentations in the bearings themselves. It would have been better to press it down very lightly. All right, now the big question is, how do we get this snap ring in into that groove? And if it's like other transmissions that have this type of snap ring, you just push. Make sure it's lined up in the groove. Yes. I'm just going to take my hammer handle. It won't quite fit. I need a smaller hammer handle. So let's try this again. Line that up. Small hammer handle. Big hammer. Not quite, just slid off to the side. Need a little more force. Aha! We're there. Okay, let me show you a picture. Snap ring installed. Now, on this access hole here with the plate, of course there is a gasket, and normally if I was putting this together for the final time, I would coat it with all gaskets. I would coat with that gasket sealer, but here at my school, we are going to take this apart again sometime in the future, because of its historical importance. So I'm just going to put it on dry for now. We'll come back to the torque on those bolts. We'll put our speedometer drive gear in while we are here, or driven gear. The drive gear is on the output shaft. And then, of course, we have a gasket for the output housing, the rear housing. It's going to go right there. So the final part to put in this output housing before we put it together is to make sure that we are lining up the notch of that cone clutch with the anchor pin that fits into the notch in the case. So we got to take this entire assembly along with the gasket that it goes with, or that goes with it. I can tell from the notch in the gasket that our anchor pin is not aligned properly. So I'm going to tap that sideways. Tiny bit. A little bit more. Okay. I believe we are there. Okay. Let's install this. All right, main shaft. It's been one of those days. Okay, that goes there. Then our output shaft. Protect our gasket. Try to get our gears lined up. Our main shaft with the sun gear on it has to mesh with the planet gears of our output shaft. So I might be able to turn that just slightly. I'm thinking I've got to... Might be helpful if I could rotate this up. Relieve some stress on my poor arms. There we go. Okay, so let's try to get this lined up here. Keeping our fingers out of the way. We've got the keyway for the cone clutch right here, but it's got to slide over into this notch right there. And then the whole thing has got to drop. Come on. Oop. Very close, very close. Cone clutch just slightly off now. Ha! We did it. Whew. Except my gasket is just off a little bit now. So we will lay this back on its side, which is how we're supposed to install it. Relieve some pressure on that gasket. Rotate it just slightly. There we go. And then we've got several bolts that we'll thread in by hand. There's one special bolt that we won't install yet. It goes right over here. That holds the park pawl or reverse anchor, depending on the model year, in place. So I'm going to rotate this back up now because I can. Okay. Let's see what the torque is on those. Okay, it tells us we need to put that parking pawl bolt in right now. So the reverse anchor or parking pawl is going to go right in here. And I've got a special sleeved bolt that will come in right there and hold that in place. Okay. 28 to 33 foot-pounds is the bolt torque on those. 28, it tells us to not torque the bolt. Okay. We have to bolt the rear planetary gear set ring gear to the output shaft, the tail shaft assembly that we just installed. And torque those to 10 to 13 foot-pounds before we can check our end play, or our end play will be too much. Nice. All right, I need to torque those to 10 to 13 foot-pounds. I need a smaller torque wrench for this one. My other one's too fat to fit in there. It tells us to reach in and press against the band and torque the bolts. Whoops, wrong direction. Okay. Okay. Those are all torqued, ready to go. So now it tells us to check the main shaft end play, how much in and out movement there is. There's a special service tool I found on eBay that is the original special service tool for this very job. It threads onto that input shaft, gives you something to hang on to. It also centers the input shaft inside of the intermediate shaft. Right there. We'll take a dial indicator. Position it on the end here. Get it centered. Alright, it tells us to pry forward on the front clutch drum. We'll zero the dial indicator at that point, and then we'll pull out and in. Looks like we went from 0 backwards about 22 thousandths of an inch. 22 thousandths of an inch. The maximum specification for this Endplay is 15 thousandths of an inch. We had 22 thousandths of an inch, which is no surprise on a transmission that is 64 years old. I have no idea how many miles are on this. It's in pretty good shape, but obviously there's too much input shaft end play. That will allow things to slam around inside there and eventually cause more wear. So they tell us to, if the end play is not within limits, to disassemble and install the correct size selective thrust washer in the counter bore of the output shaft. In the counter bore of the output shaft. So the output shaft is this big long shaft going out the back right here. In the counter bore, right back there, there's a bronze bushing and a steel selective bushing, and they come in 8 different sizes. But I don't have any of those. This is the only parts I have, so that's just how it has to be. All right, next we will install the hydraulic components and button this thing up. We're just about done. All right, the next step is to install the rear oil pump that contains the governor. So we've got the governor here, the rear oil pump here, the pickup tube. It tells us to orient the large governor weight towards the front of the transmission and then slide it down in, which I've just done. It tells us to install the oil transfer pipe that's going to go up to the front servo, and then to tighten the 2 rear oil pump bolts to 15 to 18 foot-pounds. Okay, we're going to go to 15 right there. All right. Tells us to check the governor and drive flange runout. The governor runout should not exceed 5 thousandths of an inch. If it does, we're supposed to unbolt it from the drive flange, turn it half a turn, and put it back together. So let's see if we get 5 thousandths of an inch or not. Okay, come in right here. All right, I'm going to zero the dial indicator, and we're just looking for total runout. How much total runout do we have? So we want no more than 5 thousandths of an inch. I'm going to turn the output shaft here, see how far we go. Looks like we're about 2 thousandths below the 0. and back to 0. So it looks like we've got 2, maybe 3/1000ths of an inch. That means our governor runout and flange runout are okay. Our next step is to install the front band servo, and then the rear band servo. We are going to do both of those at the same time because they have a pipe that connects the two together called a compensation pipe. The compensation pipe adds what's called compensation fluid to the servos that helps it to have more hydraulic pressure, more force holding the bands in the applied position than it normally would on pre-1952 transmissions. So 40 through 51 didn't have as much holding force as the 52 and above transmissions. The 52 and above had this variable capacity pump also. All right, so I've got the rear servo here. On this rear servo, there's a big spring right here that pushes on this rod, that pushes on this lever, that pushes down on the rear band to apply the rear band. And to release the rear band, so it's applied mechanically. To release the rear band, there's some hydraulic passages right here that come in, and there's some pistons in here. It uses pistons to push against the spring to release the band. And so this servo is going to sit right in this location. We're not ready to put the bolts in it yet because we need the front servo at the same time. The front servo has 2 pistons in it, one for the apply, or 2 for the apply, 1 for the release. It has an adjustment plug here in the top to make sure that this pin, the servo apply pin at the bottom, is at the right length. It has a special 4-3 downshift valve in this housing. This hole right here is where oil comes from the rear oil pump. It has a check valve in there that prevents front oil pump pressure from exiting out the rear oil pump. Then it has a line exhaust valve and what's called a overrun control valve in here also. This little pipe sticking out the side is the compensation passage to add additional pressure on these 1952 and later transmissions. And so we need this pin right here to go in this band servo hole. So we're going to try to get that in there. We've got to line up an oil pressure or an oil pump pipe from the pump to the servo and the compensation port to the rear servo all at the same time, along with getting the oil feed pipe from the rear oil pump lined up. So we've got 1, 2, 3, 4 things that have to line up all at once when you install these servos. I've found it's easier to hook the compensation ports together first, and then the rear oil pump pipe. Making sure that we're down on our band anchor pin, which we are. And then the last pipe to line up is the oil feed pipe from the oil pump. And there we go. It was not that easy the first time. The first time I did that. So now we've got some bolts to hold all those in place. Get all those started. All right, the bolts are 23 to 28 foot-pounds. And then it tells us to retighten the front oil pump bolts to 10 to 13 at this point. The reason we didn't tighten them before was because we had to get the pressure regulator valve in and the oil feed pipe aligned with, the rear servo, front servo, at the same time. 23 to 28. 23. Okay. And then the front oil pump bolts 10 to 13. 10. All right, then we have a few more pipes to install. We have the governor input pressure, basically line pressure coming from the pump, going back here to feed the governor. So we'll put that in its hole down below, line it up here, and then we take a soft hammer, drive them down till they stop. Oops, I forgot one. I have to take the other one out. Yep, I do. All right, to get them out, we'll just pry up lightly. Okay, slide that out of the way. There's a rear band apply fluid passage that goes from the front servo's 4-3 downshift valve to the rear band. So we'll tap that in place. And then our governor feed. We have our oil pump pickup tube. With its own O-ring. Fits right there. And we are ready for the filter. Actually, it's not a filter, it's a screen. So let's take some pictures here of how this is assembled. We'll come through the side here, front band, rear band, governor, and our parking pawl / reverse anchor. Here's our oil screen. It goes into the front pump first and then the rear. The oil pan will hold that in place. Okay. And then the next thing is our parking brake bracket and transmission control valve body. So on the side of the governor here, we have 3 cast iron seal rings. As we install the valve body and the parking brake bracket / governor housing, we have to be real careful not to break those. So it's a good idea to lube them up. They are cast iron. They will break. They're very brittle. Then on the end of the parking brake or parking valve area, we've got this little roller that has to stay in place here that engages the reverse anchor / parking pawl. We'll glue that in place. We've got the valve body, the parking brake bracket, our gear selector right here. All of this, we've got 2 different pieces that come apart that are held together by 2 pipes, governor 1 pressure, governor 2 pressure. This pipe here feeds fluid through this passage to that cone clutch in the back of the transmission, and then our governor spins inside of this housing. It does have a tapered edge on it, so as we put that on, oh, we can't put it on yet. We've got to remove the, remember they told us not to torque the bolt for the reverse anchor, but to get it ready, we've got to kind of put all that in at the same time. It helps to rotate the governor housing. As you install these pieces, I forgot to line up my rear cone clutch pipe. Get our parking brake lever, our parking gear lever in place. I found that if that last cast iron seal ring does not want to seal, or does not want to go on easily, don't force it, it'll just break. Instead, come in and rotate that governor gear. What do I do with that big screwdriver? Here it is. So if we rotate our output housing and turn the governor at the same time we're pushing in, there we go. It helps those cast iron seal rings line up and get in place. Now we'll get our reverse anchor bolt back in. Okay, these back bolts are starting. You got to get them all in at once and not tighten any of them until you get them all tightened. Obviously you wouldn't leave labels in place there, but this is a training transmission. So I'm going to leave labels on those surfaces. Ah, that's what it was. It had slid back just a little too far. There we go. Okay. The governor 1 and governor 2 pipes that connect the valve body to the governor housing back here give you a little room for rotation. So now I'm going to run these in by hand. Okay. A couple of 9/16ths back here. There's a special locking bracket that needs to be bent over this one upper bolt before it's reassembled, or before the side cover's put on. I'm not going to bend that because it'll just break over time the more I take this thing apart. Let's see what the torque is on those. So 6 to 8 and 15 to 18. All right. Typical valve body torque, not much at all. There's 6. Is that 9/16ths? Yes, it is. And then 15. 15 on these outer ones. All right. Then we have one more pipe right here. This is the reverse boost pipe that goes to our pressure regulator valve here on the side of the transmission. We'll get that lined up. Got that in. All right, there's a couple of seals right here on the manual valve and the throttle valve where it sticks through the side pan of the transmission. Oil pan 10 to 13. Side cover 10 to 13. All right, so we've got just about done here. We've got the oil pan gasket. There we go. Right there. Oil pan bolts are 10 to 13 foot-pounds. I would normally put just a little bit of that gasket shellac on there. And then we've got the side pan gasket that fits on here also. Just going to take a few final pictures before we bolt this cover on. Our oil pan has a drain plug with a copper washer. You want to make sure that the bolt holes have not been over tightened and recessed up in. This one has been. So someone's over torqued this and it's actually bent the metal by squishing it up into the gasket because they didn't go with the 10 to 13 foot-pounds, which is not very much torque, and you can easily overdo that by hand or with any type of air or electric tool. If I was going to be putting this together to go in a vehicle, I would want to go over and flatten that out on the arbor press, put a block of metal under it, push it down and flatten it out. But for classroom here, I'm just going to put it together just the way it is. It's a good example of what not to do to show my students. Torquing these bolts is critical if you don't want them to leak. Also, do not coat them with RTV. That gasket sealer I showed you before, that paint-on sealer, even that can cause the gasket to kind of slip to one side or the other while you are torquing the bolts in place. Personally, I prefer putting the gasket on dry and having with everything flat, a dry gasket on a dry pan, on a dry case will hold just fine. But when you start slopping all the goo on it, it can cause it to slip. Start all these by hand so you don't strip any of them out with any type of power tool. These bolts only have some star washers on them. They do not have copper gaskets. The side cover bolts do have copper gaskets. If you read the instructions, it tells you the bolts that are closest to the oil pan should have copper gaskets on them, and all the rest should have lock washers on them. This transmission had copper gaskets on all of the side bolts, which is fine. Even this little speed wrench can over torque these bolts quite easily. And we'll go back to 30 and tighten this last bolt that holds the reverse anchor in. It has a special metal bracket to keep it from coming loose as well. Okay. All right. Here's our side cover. That seal that I showed you goes under that pan right there. All of these bolts, as you can see, have copper seal washers on them. If I was going to do this for real, I would be installing new copper gaskets, which I've got right here. Side cover, 10 foot-pounds, same as the other. I'm only going to 8 foot-pounds. One of the bolts started to stretch. I could feel it before it hit 10. So I'll have to replace that one. That's the problem with reusing bolts. After a while, they start to stretch if somebody over torques them, especially. Yeah. All right, let's flip this thing over on its back, or on its belly. Here we go. There's a dipstick hole right back here for our dipstick. Dipstick has a breather in it. It's a pretty tight fit. Then we have our band adjusting bolts here, and an oil pressure tap and our line pressure regulator right there. So let's just talk about the band adjustment for a moment. Let me get the special tool for that. The original tool from Kentmore Tools has a handle that will loosen this outer nut, and then a adjustable socket as far as depth for the inner nut. So we will line that up. Here we go, and it tells us for the front band adjustment, tighten the screw to 7 foot-pounds. So I'm going to tighten it first, right there. And then we would tighten that. Oh, that tool's got some some dirt in it. Guess I should have cleaned it out before I started. Tighten that to 7 foot-pounds. So we just get a crow's foot, torque that to 7 foot-pounds, and then back the screw off 8 turns on this particular model. There is a counter on the top of the tool here. I'm just going to set that to 0 right there and back it off. Whoops. What's going on here? Okay. Got it engaged. Let me set it to 0. Then I'll back it off 8 turns. Right there. All right. That's 8 turns. And then, of course, you would torque this outer nut to keep it from rotating. Wow, that is filthy. I'm sure it's got years of dirt and grease from transmissions being on there. The rear band adjustment, they want the engine running at 1,000 RPM because remember it's already applied when the engine is off. And then you tighten the inner screw to 5 foot-pounds and then back it off only 2 turns. Now I've really loosened this outer one, or the inner one to install the band. It makes it a lot easier, so I'm going to run that down. till it bottoms. So let's pretend that was in the vehicle with the engine running. In neutral, tighten to 5 foot-pounds, then back it off 2 full turns. So there's a half, 1, 1.5, 2. And then lock the outer nut to whatever torque that is supposed to be locked at. That is the band adjustment procedure, or something similar to it. I'm sure there's a difference from vehicle to vehicle. Model year to model year, but as you can see, both band anchor pins are about the same height. With that adjustment procedure, I can still rotate the counter shaft, all 3 shafts. It's not locked up. Okay, right here on the side, we've just got the linkage to connect up. Okay, so we've got 2 pieces of linkage. There are some splines at the bottom down here that force the gear selector to only go on in one orientation. So that's reverse, low, drive 3, drive 4, and neutral. This uses a big Phillips head bolt to tighten that up. Okay, so I'll get that on there. Must be off. There we go. Number 3 Phillips. Tightens that up. And then we have our throttle valve linkage that connects to the carburetor that goes on next. I believe that's upside. No, that's got to be. The floorboard's right here, so it's got to be like this. All right, here on the side of the transmission, we've got our gear selector, as I've discussed, but now we've got our throttle valve linkage right here. So this linkage moves back and forth with that big long piece of linkage I showed you in a previous video that would hook to a carburetor. And as you step on the throttle, it would pull on, or push, depending on where the linkage was, on this lever, and that would give us what's called throttle valve pressure, which would increase at wide open throttle, decrease at idle. It was variable in between idle and wide open throttle, and that would fight governor pressure for the position of the shift valve. We've got the governor trying to cause upshifts, but it can also delay downshifts, fighting for the position of a shift valve, throttle valve pressure, and a spring on the other side that will cause downshifts if the governor pressure is low enough, or delay upshifts depending on vehicle speed. So this is the equivalent of your throttle position sensor on a vehicle today, except it was a mechanical input to the analog computer, the hydraulic computer inside of this, the valve body. So this valve body has 3 main inputs. Your gear selector, which gear range you want. You want reverse, low, drive 3, drive 4, neutral. Your throttle position, and then your vehicle speed off of the governor, driven off of that rear oil pump. And with those 3 inputs, they were able to decide when to upshift each gear, when to downshift each gear, just to give you an idea of there are how many ways can you downshift a transmission. You can just let off the throttle and downshift. You can move your gear selector and downshift. You can go to a wide open throttle downshift. There's a part throttle downshift, depending on how fast you're going and what speed you're in. So there's at least 4 different ways to downshift, and they have valves in here to try to accommodate each of those. So that is what's really cool about these old transmissions, clear up until the electronic controlled transmissions. And then they use a throttle position sensor, a vehicle speed sensor. Still have they have a sensor for the position of your gear selector. Inputs to a computer, so the same 3 main inputs and a bunch of minor inputs, and then shift solenoids that would cause shift valves to move instead. All right, the last thing I want to do on this transmission, and then we are done, is to install the fluid coupling. So I am not going to remove the transmission from this fixture for my classes. I'm just going to leave it here, which means I'm not going to put on the bell housing, because I want my students to be able to see the components of the fluid coupling. So we've got 3 rotating shafts here. Our main shaft right here, our intermediate shaft, and our input, or our front internal gear, front ring gear. There is a cast iron seal ring right here that is going to seal to the Taurus cover. I'm going to bring that Taurus cover over here. I'm going to put some lubrication on the inside here where that cast iron seal ring is going to seal, and then I'm going to put some on the outside here where the oil seal is supposed to seal. And then with the bell housing installed, normally you would come in and let that drop down into place. So that is our first of the 3 shafts I just showed you. The next shaft is in modern terms, our impeller. In olden day terms, it was called the driving Taurus member, and it's going to spline right to our intermediate shaft. So the Taurus cover splines to that input sun gear, or input planetary gear. Now our impeller is going to spline to the intermediate shaft. And there's a snap ring that will hold that in place in this groove right here. So let me get the snap ring. Okay, so we'll install that snap ring. Okay. Then we've got another snap ring that will prevent the equivalent of today's turbine from going on too far. Right there. So we've got those 2 snap rings installed. And then finally, the equivalent of the turbine in a modern automatic transmission. Olden day term, a driven Taurus member. And then our lock plate and our nut. That nut needs to be installed. Oh, main shaft nut, 50 to 60 foot-pounds. And then the cover bolts that go on here are 70 to 75 foot-pounds for the bell housing that would have normally gone on here. I'm not seeing the bolt torque for the flywheel to Taurus. Bolts. There's a special gasket, of course. There's a flatness check. There's a runout test. Got our flywheel. There's a gasket that goes on the back here that would seal to the back of the crankshaft. And then this gasket seals. Oops. Let's see, there's an alignment mark here somewhere. That yellow stripe right there would go with this yellow stripe. So that means this pin goes over here. And this one goes here. Just like that. All right, and then we've got the bolts that go up through that hold that in place. There are 30 of those bolts. They are a grade 8 bolt, and they use a lock washer. On these bolts, you would definitely want to make sure that they are all the same length, the same lock washer. Otherwise, you could be causing an imbalance to occur that would just simply be because these bolts act like weights. So I'm just going to put a couple of bolts in to hold that cover on instead of all 30 of them, because I want to be able to take this off and show my students occasionally. And we've got a gasket that goes right there. All right. This brings this 5-part video series on the original 1940 Hydra-Matic transmission, the world's first mass-produced automatic transmission, to an end. It's been quite a project. I've really enjoyed it. This is the first generation Hydra-Matic. Come to find out, there's a second generation and a third generation, and I will be doing videos on both of those and comparing advances in the fluid coupling over the years with this original one, along with advances in transmission technology. I've got some additional transmissions we'll look at besides that, the original Power Glide, and a few others that are significant in the history of automatic transmissions. And why do I like this? For me, I feel that I've got a good handle on today's modern technology. The 6, 7, 8, 9, 10-speed transmissions. I don't feel super challenged by those. I mean, yes, they're complex. They have a lot of parts, and the electronics and the diagnostics on those are involved. But for me, to be able to go back and see where it all started, it helps me to see the evolution, the progression over the years, and understand why certain things were done and why we ended up with certain parts in a transmissions, certain transmissions that were used for a long period of time or a short period of time, and so on. Once again, a big thank you to Aaron Severson from 8upwithmotor.com for his fantastic help and information on these old transmissions that were built long before I was born, long before a lot of people were born. So it's very humbling to see There's a whole bunch of old technology out there that is very high tech, very advanced, very complex, even by today's standards. I think sometimes I look at today's technology and think, oh, this is something really neat and new, and then find out that another engine or transmission or vehicle used it many, many years ago, and they're just bringing it back in a different form today. All right, well, this is the Weber Auto YouTube channel. Thank you for watching.